NASA's Artemis 1 Orion spacecraft is on its way back home after completing its distant retrograde lunar orbit around the Moon. The extended orbit took the mission to the most distant point ever reached from Earth by a human-rated spacecraft, some 435,000 kilometres. That easily eclipses the 400,171 kilometres reached by Apollo 13 back in 1970, and that was over half a century ago. The distant retrograde departure manoeuvre took place on December 1st, and it involved a 105-second engine burn. Orion had earlier performed a planned orbital maintenance burn designed to maintain the spacecraft's trajectory and decrease its velocity ahead of its December 1st departure from distant retrograde orbit. During the maintenance burn, Orion used 6 of its auxiliary thrusters on the European service module, firing them for 95 seconds. That 95-second burn was initially planned to be far shorter in duration, but it was increased to add additional test objectives to the mission. It gave mission managers additional data to characterize the thrusters and their radiative heat effect on the spacecraft's solar array wings in order to help fill in Orion's operational constraints. All previous thruster burns were just 17 seconds or less. The 105-second departure maneuver burn took Orion out of distant retrograde orbit and placed it on a close trajectory to the Moon. As the spacecraft swooped past the Moon on December 5th, it undertook a return-powered flyby. The 6-day distant retrograde orbit stretched over 95,000 kilometres above the lunar surface, and it allowed mission managers and engineers to push several aspects of the unmanned Orion spacecraft to its limits, tests needed to understand the spacecraft in deep space missions. These include Orion's main propulsion systems, such as its Orbital Maneuvering System, or OMS, which was originally built and used on the Space Shuttle fleet. Then there's the 8 R4D auxiliary thrusters and the 12 RCS, or Reaction Control System thrusters. Orion's communication and navigation systems and its ability to handle radiation events were also tested. In order to gather more data on the spacecraft's capabilities, mission managers have now elected to add 4 additional test objectives to Orion's return trip to Earth. 2 of these will evaluate whether opening and closing the pressure control assembly valve will affect a slow leak in that system. A third will demonstrate Orion's ability to perform attitude maneuvers at a rate that would be necessary for a test on Artemis 2. And a fourth will test Orion's capabilities of flying in a 3 degree of freedom attitude control mode, as opposed to the 6 degrees of freedom mode it typically flies in. Of course, the last big test of the mission will be Orion's heat shield, as it slams into the Earth's atmosphere at over 40,000 km per hour on December the 11th. Artemis 1 mission manager Mike Sarafin says the Artemis team are continuing to collect flight data and buy down on the risk for a manned flight, learning how the system is performing, where the margins are, and how to operate and work with the vehicle as an integrated team. Now, if the final days of the flight continue as smoothly as the mission has gone so far, the next launch of the SLS rocket and Orion spacecraft will be the first manned mission, Artemis 2, which at this stage is slated for 2024. That will orbit the Moon, but not land. And it will be followed by Artemis 3 in 2025, which will take humans back to the lunar surface, landing near the Moon's south pole. After more lunar missions, Artemis will ultimately be used to take humans to Mars and beyond. Meanwhile, it's been revealed that the launch of the world's most powerful rocket, the Space Launch System, or SLS, caused relatively little damage to the launch pad, despite blowing some 8.8 million pounds of thrust during liftoff. Sarafin says the damage was confined to just a couple of areas on Zero Deck. That's the section of the mobile launcher platform that bears the brunt of the rocket engines at liftoff. The damage included discoloration and peeling of paintwork on the launch pad, destruction of 2 cameras, damage to a pair of elevator doors, which were blown out by the intense pressure of the launch, and damage to some pneumatic lines associated with gaseous hydrogen and helium supplies, which triggered some low oxygen readings until the leaks in the pneumatic lines were isolated. Throat plug material from the solid rocket boosters, which was designed to be expelled at liftoff, was found on the ground after the launch, as was caulking from the Orion capsule, which may have been removed during the launch or during Hurricane Nicole, which hit Space Launch Complex 39B at the Kennedy Space Center a week before liftoff. NASA have also released details of the status of the 10 CubeSats, which were launched from the interstage ring of the SLS's interim cryogenic propulsion stage after it was jettisoned by Orion. These 6-unit CubeSats were built by either NASA or partner space agencies, research institutes and universities, or by commercial space companies, and they were designed to perform a variety of experiments under deep space conditions. While all were deployed successfully, 6 have either failed to make contact with their mission managers or have experienced problems since deployment, with their current positions unknown. The teams behind these missions are continuing to troubleshoot the issues affecting their spacecraft. This report from NASA TV explains how it was all supposed to work.
T-minus 10, 9, 8, 7, 6, 4, 3, 2, 1, and liftoff.
SLS is the largest and most powerful American rocket since the Saturn V, and will eventually send humans farther into space than ever before. 2 minutes into the flight, the twin solid rocket boosters burn out. About 10 minutes after the Orion and its service module escape the pull of Earth's gravity, the two will disconnect and Orion will proceed toward the Moon. On the SLS second stage, housed within the multi-stage adapter, are multiple small spacecraft known as CubeSats. CubeSats are about the size of a large shoebox and weigh less than 30 pounds each. SLS is carrying these CubeSats piggyback, which will give them a low-cost ride into deep space. Once Orion is a safe distance away, the small payloads begin to be deployed. The dispensers on the adapter ring completely isolate the CubeSats from the SLS. They require no power and operate completely independently of the rocket. One of these CubeSats is called Near-Earth Asteroid Scout, or NEA Scout, a new capability for exploration. Low-cost reconnaissance of asteroids. Asteroids to which we may one day send human explorers. Shortly after the NEA Scout CubeSat is ejected from the SLS, solar panels deploy to provide the spacecraft with power. Next will be unfurled an 85 square meter solar sail. The sail, the length of a school bus, reflects sunlight and is the spacecraft's propulsion system. This is the largest solar sail ever deployed by the United States. NEA Scout will fly by the Moon, which will help send it on its way to the target asteroid. The key to enabling this low-cost reconnaissance capability is the propulsion system that will enable the NEA Scout to go from near-Earth space to a deep space rendezvous with an asteroid. Using the sunlight pressure, NEA Scout will continuously alter its trajectory as it moves toward its asteroid rendezvous. Sunlight particles, or photons, which in this case behave like tiny ping-pong balls as they bounce off the sail, push on the sail as they reflect from it. And since the sun is always shining, the thrust is continuous. However, it is very small, on the order of an ounce of force per football field of area. Once at the asteroid, NEA Scout's onboard camera will image its surface in detail, answering many questions about the asteroid's composition and history. Exploration Mission 1 will serve as a proving ground for the integrated Orion spacecraft and the Space Launch System. In addition, it will provide an enabling capability for flying interplanetary small spacecraft for science and exploration.
This is SpaceTime. Still to come, possible organic compounds found on Mars, and astrophysicists to begin hunting for the second closest supermassive black hole to Earth. All that and more still to come on SpaceTime. Scientists are reporting the detection of more possible organic compounds on the red planet Mars. The new findings, reported in the journal Science, follow the analysis of multiple rocks found at the bottom of Jezero crater by NASA's Mars Perseverance rover, revealing significant interaction between rocks and liquid water. Those rocks also contain evidence consistent with the presence of organic compounds. Now, let's get one thing straight here. The existence of organic compounds, that is, chemical compounds with carbon-hydrogen bonds, is not direct evidence of life. See, these compounds could be created biologically, but they can also be created through non-biological processes. However, these samples, together with the new ones, will be returned to Earth for more detailed laboratory analysis in the upcoming sample return mission with the European Space Agency. Perseverance previously found organic compounds at Jezero Delta, where sediments washed down from further upstream settled. Mission scientists are especially interested in the Jezero Delta region because these formations can preserve microorganisms. Deltas are created when rivers transporting fine-grained sediments enter a deeper, slower-moving body of water. As the river water spreads out, it abruptly slows down, depositing the suspended sediments it was carrying and trapping and preserving any microorganisms that may exist in the water. However, the crater floor where the rover landed before travelling to the delta was more of a mystery. In lake beds, the researchers expected to find sedimentary rocks. That's because the water deposits layer after layer of sediments. However, when the rover touched down, some researchers were surprised to find mostly igneous rocks, that is, cooled magma on the crater floor, and the minerals in them recorded not just the igneous processes, but also significant contact with water. These minerals, such as carbonates and salts, require water to circulate in the igneous rocks, in the process carving out niches and depositing dissolved minerals in areas like voids and cracks. In some places, the data shows clear evidence for organics within these potentially habitable niches. The minerals and co-located possible organic compounds were discovered using SHERLOC. SHERLOC stands for Scanning Habitable Environments, with Raman and Luminescence for Organics and Chemicals instrument. Mounted on the rover's robotic arm, SHERLOC is equipped with a number of tools, including a Raman spectrometer that uses a specific type of luminescence to search for organic compounds. It can also see how they can be distributed in a material, providing insights into how they were preserved at that location. As the rover rolled towards the delta, it took numerous samples from the water-altered igneous rocks, and it since cached them for future sample return. The samples need to be returned to Earth so they can be examined in larger, more fully equipped laboratories. After all, there's only so much equipment you can put on a car-sized rover that's heading for another planet. The advanced instrumentation available on Earth will allow scientists to determine definitively presence and type of organics and whether they've got anything at all to do with life. This is SpaceTime. Still to come, astrophysicists hunting for the second closest supermassive black hole to Earth. Beijing announces its latest plans for a moon base. And later in the science report, the world's largest volcano, Hawaii's Mauna Loa, erupts for the first time in 40 years. All that and more still to come on SpaceTime. Two astrophysicists have suggested a new way to observe what could be the second closest supermassive black hole to Earth, a behemoth some 3 million times the mass of our Sun, located in the dwarf galaxy Leo 1. The supermassive black hole, labelled Leo 1 star, was first proposed by an independent team of astronomers back in late 2021. The authors noticed stars picking up speed as they approached the centre of that galaxy. That's clear evidence of a black hole. But directly imaging emissions from the black hole wasn't possible. Now, Avi Loeb and Fabio Picuzzi from the Harvard-Smithsonian Center for Astrophysics have published a study in the astrophysical journal Letters suggesting a new way to verify the supermassive black hole's existence. Picuzzi says black holes are very elusive objects, which sometimes enjoy playing hide-and-seek. Rays of light can't escape their event horizon, but the environment around them can be extremely bright, and if enough material falls into their gravitational well, it can be detected. However, if the black hole is not accreting any mass, in other words, if it's not feeding, it emits no light and becomes impossible to detect. This is the challenge with Leo 1, a dwarf galaxy so devoid of gas available to accrete into it that it's often described as a fossil. But Loeb and Picuzzi claim that a small amount of mass loss from stars wandering around the black hole could provide the accretion rate needed to observe it. Picuzzi points out the fact that old stars become big bloated red giants. And red giants typically have strong winds that carry a fraction of their mass into the surrounding interstellar space environment. And if the space around Leo 1 star contains enough of this material from these ancient stars, there should be some observability there. Loeb says if they're right, observing Leo 1's star could be groundbreaking. It will be the second closest supermassive black hole to the Earth after Sagittarius A star, the one at the centre of our own galaxy, the Milky Way, and which is located some 27,000 light-years away. Sagittarius A star has some 4.3 million times the mass of the Sun, and Leo 1 star has a very similar mass range. But it's hosted in a galaxy that's 1,000 times less massive than the Milky Way. And this fact challenges everything astronomers know about how galaxies and their central supermassive black holes co-evolve. How did such an oversized baby end up being born in such a slim parent? Decades of studies have shown that the most massive galaxies all host supermassive black holes in their centers. And the mass of the black hole is usually about 0.1% of the total mass of the spheroid of stars surrounding it. Loeb says if this rule was true, then in the case of Leo 1, scientists would expect to see a much smaller black hole. Instead, Leo 1 appears to contain a supermassive black hole 3 million times the mass of our Sun, and that's very similar to the one hosted by the Milky Way. And this makes it all very exciting, because science usually advances the most when the unexpected happens. China says it'll establish a lunar base at the Moon's South Pole by 2028. The outpost will be based on 2 robotic exploration missions and will be followed by a Chinese manned lunar mission in the 2030s. The announcement follows the completion of China's Tiangong, or Heavenly Palace space station, and last week's launch of 3 more Taikonauts to the orbiting outpost, replacing the Shenzhou 14 crew currently on station. The Shenzhou 15 launched from the Jiuquan Satellite Launch Center in northwestern China's Inner Mongolia aboard a Long March 2F rocket. The crew are expected to carry out 3 to 4 spacewalks and continue working on payloads both inside and outside the space station. The director of China's Deep Space Exploration Laboratory, Wu Riren, says lunar exploration is one of 4 major targets planned by China's space program. The others include asteroid and planetary exploration and a new heavy-lift rocket powerful enough to undertake manned missions to the Moon and Mars. Of course, in 2004, China began Project Chang'e to use robotic missions to explore the lunar surface. These culminated with the Chang'e 5 lunar sample return mission in 2020. Wu says the next steps will include another sample return mission with Chang'e 6, while Chang'e's 7 and 8 will explore the Moon's South Pole in greater detail and lay the foundation for a manned outpost. China and Russia have already announced plans for a joint manned lunar outpost later this decade. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.